All right, today we're going to be talking about this NXP smart voice interface voice eval board. Basically, here's the part number right here, and that's what the little eval board looks like. That little SAW module right there is pretty much ready for production needs if you wanted to use it like that way. The rest of the carrier board's got a speaker on it with some microphones. So the first thing we're going to do is if you search this part number on the NXP website, it would be bringing up this Edge Ready I.MX RT 106V based smart voice user interface solution. One of the first things you need to do is when you get on this page, you can go to scroll down a little bit and go to the software. We're going to need to get these files right here. You probably don't need the Conversa, but you definitely need these other files. Get those, as well as when you come up for the Getting Started button. If you scroll down a little bit, you'll see the initial update. Here's some IoT tools. You'd want to click on that, get those zip files to be able to go through and do a DOS update on this particular eval board. After you download all these zip files, these are the zip files that I have, you can expand them out, and this libs folder right here, you'll have all these .a files in there. You need to drop those into your project in your workspace in order for it to compile correctly. And then you got design files for schematics, bill of materials, things of that nature. The IoT tools is some scripts to update different images for the first time. If you don't want to get into an IDE and create a project yourself, you can initialize it with all these images that here's some of the images in here. You can get those injected into this board here, and then this library right here is an evaluation one. If you're going to use this solution, you'll have to get the file that says production on the end of it. Okay, so let's go back. Okay, so what we're going to do is get this thing ready to be downloaded to. So we're going to move this jumper to where the jumper is closer to the button side than to the speaker side. Right here, we'll move that jumper. It's in place. At that point, we can plug this thing in here and apply power, and it won't really do anything. Let's bring up the DOS window now. Moving back into the tools folder where we're going to do the updater, we'll notice there's a bat file in here, flash SVUI_board.bat. So we'll come up here to the Explorer window and type in CMD, bring up a DOS window, and dir. So here we got the flash updater here. So we'll just run that bat command, and as you can see, it's going to be updating the flash of this guy. So it's basically, here's the external SPI flash. I think that's 256 megabytes. External SPI flash. This particular I.MX RT does not have any internal flash in it, so we need to run this script. So it's going to continue to run, and it's loading up the freshest demo projects for us. So we'll let that continue on. Later on, instead of running it from the DOS window, we're going to come over here and we're going to use this project that's over here. It's the local demo, and we can compile it within the Espresso. Okay, so the flash is successfully written. So what I'm going to do is I'll unplug the power, switch the jumper to pins 1 and 2, and then when I plug this back in, it's going to start running here. Okay, I ran through this flash programming bat file again because
HVAC demo.
This is what you should be seeing over here. So once again, when I was programming it, I had to move the jumper wires. So we have to shut off the power, move the jumper wire back to the other pins 1 and 2, turn it back on.
HVAC demo.
Now we have the demos running. If we push this button 2,
oven demo. Smart home demo.
it can move through the different demos.
HVAC demo. Oven demo. Smart home demo.
So we're on the smart home demo. If you select this button, which I think is maybe button 1,
Smart home demo.
it tells you what demo you're on.
Smart home demo.
Okay, so let's lower that down. So at this point, we can say, hey NXP. That's our wake word. Turn out the lights.
Okay, lights off.
Okay, so now it's registering commands. So that's good. And let's see here. Let's close that down. If we open up a COM port, we should be able to type in help here, and these are in the command shell. What things you can do. Let's type in commands. Command. Nope. Okay. I guess commands, it doesn't work. Commands. Okay, let's try that again. Commands. Okay. So if you do commands, this gives you an example for the home demo, English language, the wake word, and then example expressions that you can say. Set the brightness level to max in the kitchen, turn up light brightness by 20% in the bedroom. So a bunch of different expressions that you can use that have been pre-programmed into the project. So that kind of shows you how to freshen up the project flash in here. Now let's say if you made some changes to the project file and you customize it, we'll show you how to flash it. Okay, so next what we're going to do is when we're in Espresso here, if we're starting from scratch, you can say import application code hub, and then from here we could type in 106V, and it brings up this Smart Voice user interface solution. If we click on that, it will bring up how to install the SDK and the software within the Espresso, so you can follow along with this. Now when I typed in this particular eval information in here, I don't think I found a C version, but there were some other versions in there that I was able to use. So you go through and just select all the check boxes in the SDK when you're building it up. So once you do that, You get the SDK inside of Espresso, and some of these other steps are optional. And then you can go here. That's for your tool package. Get that. And once again, this is pre-configured updater that we just looked at. And then over here you've got some images. And then this is showing you which jumpers you have to move for downloading. So we got that. And then eventually when you get your projects in Espresso, you can then start to change them. So go through these particular steps, and you'll get the projects inside of your Espresso. Yeah, one thing that I want to point out is, let me shut this down. Like in my Project Explorer right now, if I go and pull up this SLN-SVUI-IOT local demo, that's the one that I've been using. If you come in here, you see there's a lib folder here. I added that manually. So in the zip files that we downloaded earlier, which is over here, here's a folder. This is this lib file. So what I did is I copied this folder here, and then I had to go find out where the workbench was at, or workspace. So if you come over here, switch workspaces, you can kind of see where the path is going over here to some workspaces. So at this point, I can come and go over to my, I think, documents folder, and here's the workspace that I'm in. So I'm in here, and then I find the project that I'm in, and inside of here, originally this libs folder was not in there, and it wouldn't compile. So you need to drop this folder in any project that is going to be using the voice commands and some of the IoT stuff, I believe. So once you get it in there, as shown in this Project Explorer, you can then go to that project and build it, and the project will build. And as we can see in the binary, it's going to make this .axf file. Once you have that file, then you can program it into this module. So next we're going to pull up this other tool, which is the MCU Espresso Secure Provisioning tool. So the first thing we need to do when we bring that up is we got to go pick the right processor. So we're going to do the 1060, and then we can also, when we're doing that, we can also come over here and check the connection. It failed right now. Test the connection. It failed because the jumper is not in the right spot. So we're gonna unplug the power, move the jumper over closer to the buttons, and then we'll hit test connection, and it says okay now. So once again, we went up to tools or target and hit connection and test it, and it's working. So we say okay, that's great. And then the first thing we want to do is we want to select the target here via USB interface, and then we have the boot mode is unsigned image, and it's using the Flexi SPI NOR flash. I think when I was also doing this, I had to go to the flash programmer under tools, and maybe it wasn't there. Let me see here. Processor, maybe? No. Here, let's see. Let's go under the connection there. Boot memory? Aha, there it is. So under boot memory, what you can do is you can run this test button here, and it's going to go through and try to talk to the flash up here, the SPI flash. When I did this, it said I needed to adjust the memory size because the memory type, which was this W25Q, I don't have the 128. I have a 256 there, so I had to increase this memory size by a number 2. And it popped up a dialog window, and it asked me if I wanted to do that. So I said, let's do that. So anyway, right now we have a success with the test, which is great. At this point, what we're going to do is we're going to click on this Build Image tab, and we're going to go Browse, and we're going to go to the workspace, and then in the debug folder, we're going to scroll down, and we'll see .axf. So we'll select that one. Let's see here. I think it automatically put the starting address, which was correct. And then from there, you can hit on the right side, Build Image button. And it's going to go off and build that image, and it'll create a binary. So we'll hit Close. That was successful. So here's our binary it created. Now we're going to come up on a different tab, Write Image tab. And at this point, we're just going to hit the Write Image, and it's going to program the image into this board here, because we've got the jumper up here move towards the buttons. So we're going to let that complete. This is how you target the external SPI flash with some customized code that you're working on. So that is complete. So at this point, what we can do is we can unplug the power, move that jumper back over to pins 1 and 2, and plug this back in.
Smart home demo.
And then now we're up and running with the code that was defined over here in the Project Explorer. Once again, if you say, "Hey NXP," you'll see the blue LED light up.
Okay, lights off.
And then give it a command, and it'll process whatever command that is, if it understands your voice. Also, I wanted to say on this platform, there is some tie-in to Wi-Fi and Matter, and you can put voice commands in, and then here's your Wi-Fi module here. It will send information over to a Matter server to let's say close some shades, turn some lights on, dim them, things of that nature. So I haven't got that running with this project here yet, but evidently you can do that. Also on the back of this carrier board, there's some microphones on the back that allow you to change where the microphones are at. I think there's some microphones up here on this board as well. If you want the mics to be shut off, there's a little switch up here. You can move down, and now you're basically in the mute state. And then if you turn that switch back on, the LED goes off, and you can say, hey NXP, and issue a command. Turn off the lights.
Okay, lights off.
So that's a little bit on how you get started with using MCU Espresso projects and using the provisioning tool to target the external SPI flash. So hopefully you like what you saw here, and we'll probably have to make some more videos to expand upon how to use this particular smart voice platform. Thank you.